And let's see if you know these basic parent functions. So here's one. Y equals absolute value of x. I'd like you to just sketch that real quick. Yes? Yes. Try to be sensitive to how long you're gone, to be respectful of the request. All right. So, Lydia, can you describe what you think it looks like?
Yeah, it's like a V shape.
I agree. There you go. Raise your hand if you knew that. Okay, good. Then let's try another one. What about plain old y equals x? Let's sketch what that looks like. Imagine you're like, this one is kind of weird. I mean, it's so simple, it's actually hard. So what if there was a kid who was stuck? XY chart. And if it's y equals x, and you're like, I can't remember what that looks like, well, stick in a 1 and see what you get. I'm going to put a 1 here. What would y have to equal? 1. 2 would go in, and what would y have to equal? 2. And if I put in x is 5, then it would be 5. And I think you're getting the idea. They'd be just like boom, boom, boom. Oh, yeah, it's that line. See how you can make them if you forget them. All right. I'm going to go the other way. What's that graph? Remember that one? Y equals something. Raise your hand if you feel confident. I'm pretty sure I got this one. Oh, that's a good amount of you. What do you think? Olivia?
Okay, y equals square root of x.
Y equals square root of x. Very good. And if you had trouble with that, XY chart could save the day. The thing that's weird about the square root graph is you don't want to put in like 2, because the square root of 2 is a weird decimal. So things like 0 work though. Square root of 0 is 0. Square root of 1. Square root of 1 is 1. Square root of 4 is 2. And eventually you would be recreating this graph right there. And okay, then what else did I teach you? Domain and range. What is the domain of this graph? The domain is the x values you can safely feed this function. So you start and think, okay, this way, x values go this way. Does it go forever? No. 0, 0 is the furthest left that it goes. So what's the domain? This is left to right. What's the furthest left that it goes? Lydia, what do you think?
0.
0. What's the furthest right that it goes, Ryan? Infinite. 0 to infinity. Now, one thing that's just slightly wrong. It's just a little tiny thing. I wrote it wrong. Do you know what I did wrong? Yes?
You have to use the other type of bracket.
Yep. Because it touches 0. And I know that may be like, oh, how could you not touch 0? Well, what if the graph actually looked like this? What if they had an empty spot right there, and they drew in an empty spot like that? Then they'd be saying it gets really close to 0, but it doesn't touch 0. So if it had an empty spot like that, then you'd use a parenthesis. Again, I'll keep up this. What if they had an empty spot there? Well, then you'd erase this and use a regular parenthesis around it. Like that. Okay? All right. 1 graph, 2 graphs, 3 graphs, and interesting question. What 2 points have been on every graph? Name one of the 2 points that's been on every graph. Even the V shape. Here, I'll draw the V shape in last. Okay.
0, 0.
0, 0 has been on every graph. Can you name another point? It's been on every graph so far. That spot. What do you think it is? 9, 9? No. What is it? Maybe you never noticed. 1, 1. It's been on every one of the graphs. Y equals x squared. Stick in a 1, you get a 1. Y equals absolute value of x. Stick in a 1, you get a 1. Y equals the square root of x. Stick in a 1 in the graph. Stick in a 1 right there, and you get a 1. Square root of 1 is 1. See how 1, 1 comes up a lot? Okay. All right. Now we got to talk about translations. Not like translating from English to Spanish. A translation in math is where you just move the function a little bit. So like, let's say you had a square root and it was right here. And you say, how about if I grab that? And you guys have this cool lasso on your Notability. I personally use this to explain everything, and I don't have a tool like that. So I'm just going to have to redraw mine. Do you get if I just grabbed my red graph and dragged it over to the right a little bit, it would be the blue graph? That's just me dragging this over. Well, the red one would be y equals square root of x. The blue one, see if you can catch what happened here, be the square root of x, but then minus 2. This on the inside thing here, that meant you should move it 2 to the right. Now, if you had just been asked ahead of time, hey, what's this minus 2 gonna do? Wouldn't you have thought that it would move it towards where negative 2 is? That's what most people would think. It feels like it should move to the left. But you can't trust the stuff on the inside. The stuff on the inside of absolute values or square roots or even parentheses, you don't trust it. It'll lie to you. If you all know that y equals x squared would be a parabola, that would be a parabola, except moved. Everybody write this one down. And I want you to then put an arrow and say which way it's been moved. Boy, that feels like it's been moved. Just copy the problem on the board. That feels like it's been moved right 2. And I know a lot of people are going to say right 2. Because plus 2 is to the right. You don't trust it. You don't trust things on the inside. So how many of you overcame that and said left 2? You were correct. Good job. Okay. Now, let's talk. I'll just give you a quick story, just because it's kind of a fun story, about not trusting the inside. I had a friend who spent time in jail. And he, put the smartwatch down. He said that what the people in jail called jail was the inside. They called it the inside. So he was on the inside, and he said that actually a lot of the people in there were, pretty decent people that made a stupid mistake or whatever, and but then there were some really crazy people. And he said one night his cellie had left. What do you think a cellie is? Cellmate. Your cellmate. And person that's in the cell with you. So he gets a new cellie that night. This guy came fresh in. He had just been caught. And of course, the first thing you ask somebody when they just get put in jail is, so what'd you do? Everybody's curious what they're in for. Okay, and this guy said, I stole a car. They caught me in a stolen car. And then he talked to him a little while longer about it, though, because he actually, a lot of people want to talk about it. It just is this very traumatic event just happened to him, right? And he said, what they don't know is So that's my story about not trusting the inside. He couldn't even trust this guy to sleep overnight. He didn't have a choice, but he knew that he wasn't going to just fall into a deep sleep. He said he basically just stayed up and tried to make sure that he didn't get killed during the night. All right, so anyway, the inside, everything's going to be the opposite of what you think. But the outside, that, if it says like +6, doesn't that seem like it's up 6? If you know the outside is about up and down, which it is, +6 seems like it's up 6, and you can trust it. You can trust stuff on the inside, trust stuff on the outside, but not on the inside. Don't trust. It's also called counterintuitive. Yes? No problem. All right, so this seems like it's up, and it is up. This seems like it should move to the right, but no, it actually moves to the left. All right, let's see if you really understood that. Y equals absolute value of x minus 9 absolute value. Which way do you think that moves? Kai, what do you think?
Right.
Right is correct. The right 9. What if I put a +7 over here? What would that seem like it should do?
Go up 7.
And can I trust that?
Mm-hmm.
Yep. Okay. Cool. Now, one more thing we have to learn, and that's when you do this to a function. Y equals the absolute value of x, but then I throw a negative in the front of it like this. Do you get that that's opposite of? What it does is it flips it over. It used to be a V shape like this, but now it's gone. I want you to predict in your head where you think it goes. Like that. Does that make sense to you? All right. Now, last thought. High vo. Get used to these. High goes with horizontal on inside. Vo means vertical on the outside. So that's called a vertical reflection. You know, vertical means up and down, right? That's a vertical reflection. In case you didn't know that, vertical does mean up and down. Horizontal means left and right. So what if I had this? Y equals square root of x, and then I throw a negative here, and then on the outside, I put a -8. You should be able to say, okay, that is a vertical, or is that a horizontal? Reflection, or a flip. And this does something also. So here's the normal square root graph. The parent graph is what you start with. And then what happens? High vo, horizontal on inside. That's a horizontal reflection. Everybody draw what you think it should do when I horizontally reflect it. Just draw it on your iPad, sketch what you think should happen. In a moment, I'm going to ask you to compare with the person next to you. This is the most important part. Can you take a parent graph and move it to the right place? Horizontal reflect. Horizontal means like this way. All right, compare with the person next to you and see if you horizontally reflected it the right way. Okay, did you go like this? Raise your hand if you had that right. Okay, cool. Then how about this -8? Where did that go? It's already been reflected, so now it's going to move, do you know, Noah? 8 on the inside, it would be left or right. This is on the outside. Nope. If it's on the outside, it's up and down.
Down.
Yep. It's down 8. There's where the final answer is. It started here, it flipped over to there, and then it went down there. Final answer, right there. Okay. So, when you get given a problem like this, y equals 4, let me think. You know what, not a 4. We'll say, just, hold on, wrong eraser tool. X minus 9, absolute value, plus 2. How do you do it? Well, you start and say, I know what this was when it was a baby. The parent function of it all that started off was just an absolute value of x. And I know what that looks like. Do you know what that looks like? I know that was a V shape. And then the child function, which comes from the parent function, but it's a new creation. And now it gets moved. What's that? And what's that? Well, if you know, then go ahead and move this graph to the right place. In a moment, I'll ask you to compare with the person next to you and see if you and they moved the graph in the same ways. Remember, this is high-vo. Horizontal moves are on the inside. Vertical moves are on the outside. So draw where you moved the thing, and their V should now be in a different place. Compare with the kid next to you. I'll pause for a second while you do that. Really listen close on this, because this is the critical part. This moved 9, and it feels like it should be to the left, but it's not then. It's to the right. Right 9 and up 2. So that's like over 1, 2, 3, 4, 5, 6, 7, 8, 9, and up a couple is like right there. That's where your V shape is now. Raise your hand if you had that one right. Okay, awesome. Well, how would it have been different if I would have had a negative in the front? A really common mistake answer is to put it like that. How is that a mistake? It feels right. Because it actually should be down here and upside down. Do you get how there's a little gap right there? There needs to be still a gap right there. When the thing flips over, it'll be down where this blue V is, not where the black V was. Okay, all right. This now should be mostly a review. Everybody start with this one. Do you get one end has a dot so it doesn't move anymore that direction? And the other end has an arrow, so it keeps moving in that direction? Would you write down the domain and the range? Remember, domain's about the x, range is about the y. Put it in a parenthesis with a comma. You might need a bracket somewhere too. Hint, hint. Pausing for a second. Okay, let's see if you had it right. Domain is from left to right. And so that's from... It goes way to the left. If you extended the graph out, it would go forever to the left. But the furthest to the right that it ever goes is 1. Process that. I know some of you probably had that wrong. Negative infinity to 1. The range is this way. How low does it go to how high does it go? The lowest this ever goes is 0, and the highest it ever goes is infinity. And then I got to ask myself, when I was at 1 for the domain, does it actually touch the 1? Yes, it does. That was a closed-in circle. And when I touched 0, did it actually go to 0, or did it just get really close to 0? It touched 0. So the brackets are when it touches it. There it is. Who had the domain and range right? Okay. This is a really important but tricky concept. So this is translating horizontally and vertically. Remember, it's high and low. The vertical stuff will be on the outside. The horizontal stuff will be on the inside. So if I gave you this, what function is that? Say it if you know it. Remember the one that curves kind of as like a ramp? Come on, say it if you know it. Nobody's memorized that one?
Square root of x.
Square root. So y equals square root of x. Good. And how about this one? Say it. Absolute value. Good. This one. Say it if you know it. Y equals x. And the last but not least, last but not least, the parabola. Y equals what? X squared. Good. Those are the 4 biggies. Okay. So we're going to play with Desmos at the end of the hour. It's a graphing calculator program, but we're going to finish this up first, and you'll be able to just kind of free-form mess around with these. That's left and right. Notice it's inside. Horizontal on the inside. Isn't left and right, isn't that a horizontal thing? Yep. And it's vertical on the outside. So, these are just the, what does this look like again? That looks like that. This one looks like this. And this one looks like this. I'm not sure exactly what the teacher intended for that slide, so I'm just going to keep moving. How would I make this moved down? Notice it said translated, and I just translated that to moved. Translated just means moved. Well, it would be y equals x squared. And then there's only 2 ways to do it. -7 like this, or y equals x minus 7 on the inside. It's one of those 2. So is it A or is it B? Which one would go down 7? A or B? Say it if you know it. A would go down 7. Good. Not that. That would have gone right 7. Now write the equation if it's translated right 4. Everybody write that. Yes?
Would it be plus if it was in the parentheses for that?
Good point. You're right. If it had been, it's kind of hard to say because it's supposed to be down. And so anything on the inside is wrong, no matter whether I use plus or minus. If it's gonna go down, it's gotta be on the outside. Okay, this next one, right 4, that was absolute value of x minus 4. I forgive you for thinking it was plus 4. Somebody out there said it, I'm sure. But remember, you can't trust the stuff on the inside. It's always the opposite of what you think. This last one, y equals, you could say f of x instead of y. They're the same thing. Square root of x, but then translated up 1. Here's a really common mistake. And left 6. Nope. Totally wrong. Lydia, what should be where?
6 and 1 should be switched.
Yep. And now just make sure, does that really go left 6? Feels like it goes right 6, but you can't trust the inside. So it does go left 6 and up 1. There we go. Here's your answer. Okay. Now this is, if I just said, where does this move? Your answer shouldn't be to graph it. Where does it move? Right 8. Where does this move? Josh.
That one moves to the left.
Nope, it's on the outside.
Oh, then to the right.
It's vertical on the outside. Does left and right sound like vertical to you?
It moves up.
Up 10. Okay. This one's got two parts. Noah, can you do it?
Down 2 and left 3.
Down 2, left 3. Yep. Nice job. Okay. I don't like how we're doing that, so I'd like this one though. So if they asked you to graph that, you could either start with the parent parabola, just the normal parabola, and then move it 5 to the what? And 1 where? What do you think? I agree with the down 1, but you fell into the trap. Left 5. It always seems like it should be the right, but it's actually the left. Okay, there we go. And you could go and do that. Or, I just want to remind you, I've told you this a few times, the XY chart is your best friend in graphing. You may not want to have to find all the original points perfectly and then move all of the points left 5 and then move all of the points down 1. Do you get that would be kind of tedious? You'd have to find a whole bunch of things, move them a different way, and then move them a different way again. I think you're going to choose this option. You're going to go, I'm going to just stick in a few points. I'm going to try putting in 0, and I'm going to see what I get. Everybody right now, I'd like you to put in these 5 points. -1 and +1. -2 and +2. If we put in and we graph all 5 of those points, it'll become obvious where this graph must be. So if you put in a 0, you got 5. Squared is 25. -1 is 24. Whoa, that was huge. How about -1? Got it?
15.
Double checking, yep. I'm putting the -1 in for the x, and I'm getting 4. 4 squared is 16 minus 1, 15, I think. Okay. Now I'm going to put in regular 1. Josh, put in regular 1 for me. Tell me what you get.
26.
6 squared is 36.
Oh, 36. My bad.
But then subtract the 1.
35.
There you go. And now put in -2. Did you get 3? 3 squared is 9. 9 minus 1 is 8. Who had -2 comma 8? Okay, good. Last but not least is regular 2. 2 plus 5 is 7. 7 squared is 49. Minus 1 is 48. You get some of these points are just so huge that you wouldn't want to graph them. The one that was the most reasonable was right there. And it was headed in the negative direction. We were at like -2. Let's just do a couple more points. -3 would be nice. What's happening is the inside here is getting smaller and smaller when we use like bigger and bigger negative numbers. So that's going to make -3. -3 plus 5 is 2. 2 squared is 4. 4 minus 1 is 3. Who had -3 comma 3? Okay, cool. I think you get the point. Do you get if I put a bunch of dots now on the page? All I got to do is put a bunch of dots and then play connect the dots. It's really not that hard. -2, 8. And go to -2 and then go to 1, 2, 3, 4, 5, 6, 7, 8. There's a dot right there. The next one was -3, 3. And I don't have that many dots yet. Well, then I should probably keep going. -4. I put it in. -4 plus 5 is 1. 1 squared is 1. 1 minus 1 is 0. -4, 0. I see what's happening. My parabola is forming. -5. -5 goes in, and I get 0 squared is 0. Minus 1 is -1. -5, -1. That dot's just a smidge off, but it's okay. And it would look something like that. You graph enough dots, like, oh, it's a parabola that's been moved left 5 and down 1. Okay, you made it. This would be a typical question. Beckett, can you tell me one way I could do this? Say I had to do this problem on a test. Give me a way.
So the starting point would be we go up 4 on the y-axis and to the right 1.
Yep. So if the graph looks like this in the first place, I move everything up 4 and right 1. But I'm going to have specific points. I can't be just like, well, this is kind of right about there. You'll have to have specific points. So how do I get those? XY chart. Everybody please put in -2, -1, 0, 1, and 2. And that's it. That's the last thing I'm going to ask you to do. How do I put in -2? You go over here, you put in -2 right here. And then you see what you get. Wait a minute. It doesn't even exist. It's the square root of -3. Cool. Do you guys know what DNE stands for? Does not exist. It's true. DNE. What if I put in -1? It's the square root of -2. That does not exist. What if I put in 0? Then I got 0 minus 1 is -1. The square root of -1 does not exist. How about if I put in 1? Finally, something actually exists. Square root of 0, which is 0, plus 4. 0 plus 4 is 4. Finally, I got an actual point. Over 1, up 4. Now I put in the 2. 2 minus 1 is 1. Square root of 1. This part here, square root of 1 is 1. 1 plus 4 is 5. And I know what this looks like. It's a square root that's been shifted 1 to the right and up 4. See how it looks like a square root that's been shifted 1 to the right and up 4? Cool. That was one of your hardest things. Now we're just going to play for a minute on Desmos. So I'm going to stop the video at that point.